In this lesson, we're going to focus on some of the properties of logarithms that will help us to expand or condense an expression. So there are three main properties that we want to talk about today. The first is the product property. And the product property says if you have a product of terms, that in order to expand those terms, we would just write a plus in between them. And of course, we can go backwards as well. If we have two logarithms with the same base and those are being added, then we can write them as a product. Quotient property, very similar. Of course, this has to do with a quotient rather than a product, so we're dividing. And division means to subtract. So just like we did when we had exponent properties, multiplication went with addition and subtraction went with division. The last is the power property. And the power property says if you have a logarithm that has an exponent, that exponent can be moved to the front as a constant. So we're going to use this one a lot. And again, any of these three properties can go starting on this side, going in this direction. So if I have a constant on the outside of a logarithm, I can then move it to become an exponent. So let's take a look at using those properties. So in the first one, the product property to expand the expression. So notice these are all being multiplied, so it's the log of 4ab. And therefore I can take the log, and again, always base 4 of 4, plus the log of base 4 of a, plus the log base 4 of b. Now notice on this one, the log base 4 of 4 means 4 to what power is 4, so that's 1. So I would then rewrite that as 1 plus log base 4 of a plus log base 4 of b. So if you can do some simplification, you certainly should. Same thing will happen here. This is a natural log, but it doesn't change anything. We're still using the same property. So this would be the natural log of 5 plus the natural log of e. Of course, we know the natural log of e is 1 because this is like a base of e. So e to what power is e? That gives me the natural log of 5 plus 1. The quotient property, again, we're just going to subtract instead of add. So this would be log base 2 of x minus log base 2 of 4. Log base 2 of 4 can be simplified because 2 to the second power is 4. So this is actually log base 2 of x minus 2. This one, I have the natural log of 100. And then I am subtracting, again, because it's division, the natural log of x minus y. So don't try to separate the x and the y, because we cannot do that. We can only separate them. We can't turn it back into a division or anything like that. It only goes in one direction. And the last one, use the power property. So I have this 10. The 10 can move out front. So this is actually 10 times the log base 5 of x. And this, I would first rewrite this as the natural log of x to the 2/3. Because the 2 is the exponent and the 3 is the index, and then I would rewrite this as 2/3 times the natural log of x. Here are 6 for you to try on your own, so do all 6, then press play to check your work. The first one, again, I'm using the product property, so it's a product of 9 and x, so it's log base 3 of 9 plus log base 3 of x. Because 3 to the second power is 9, that's actually 2. So 2 plus log base 3 of x. And my second one, natural log of 5x. So I have a natural log of 5 plus natural log of x. Oops. I said x, but wrote 5. So natural log of 5 plus the natural log of x. None of that can be reduced, so we would leave it just like that. Quotient property of logarithms. Here I would say this is log base 5 of, this one's going to be a little trickier because notice I threw in a product on this one. So this is log base 5 of 5 plus log base 5 of x because that was the numerator, but now I'm subtracting because that's the quotient. The denominator would be log base 5 of 4. Now log base 5 of 5 is of course 1, so that gives me 1. And then plus log base 5 of x and minus log base 5 of 4. Same thing's going to happen here. I'm going to use a couple of different properties. This is natural log, it's still a quotient. I would first write this as natural log of e to the 4x minus natural log of 2. This 4x is an exponent, so I can rewrite this as 4x. And then, of course, natural log of e, we should all know, is just 1, so that will go away. So it's just 4x, and then minus the natural log of 2. And then the power property, again, I'm going to move that 4 out front, and then log base 2 of x. And here I'll move the 5 out front, and natural log of x.